Well, hello scrappers, Mike here. Welcome back to my channel. What do we got going on today? Well, today we are going to deal with some silver. I've got a whole bunch of silver relay contacts up here, as usual, from my friend Yanni. I've got a couple of different types. These are some really big chunky ones that he brought me quite a while ago, and I unsoldered from some big heavy duty bus bars. I actually have a video and I did that. I'll put a link to that in the upper right. You can check it out if you like. And then I've got all these little bitty relay contacts. Yanni is a scrapper extraordinaire. He'll take apart hundreds and hundreds of little tiny relays and get all the contacts out of them. So he knows they're silver. He knows they're palladium. And a lot of them even appear to be gold plated. Let me give you a close-up look at these relay contacts in here. Yeah, I think we've got a lot of gold-plated relay contacts in this bag. I really think we do. So that's good. We'll get some gold and some silver in this video. Yeah, the last time Yanni brought me a bunch of relay contacts, there was an incredible amount of gold in them. So I think we're going to do pretty well with these again, too. And then I've got some scrap silver here left over from making anode bars for the silver cell. Get this turned on. I'm just going to combine it all together. There's 34 grams. Got these big chunky ones here. Now we're up to 139 grams. And now we've got all of these little bitty relay contacts. Wow, 436 grams. What is that, right around a pound? Yeah, not quite a pound. Almost. We're about, I don't know, 22 grams short. But still, that's a lot. That's well over 1 troy ounce of silver there we're going to recover from this stuff. Plus, it looks like we're going to get some gold and maybe some palladium. So, excellent. And notice, Richard, I did not weigh any of the bags this time. All right. Let me get this in the fume hood, and we're going to start dissolving this stuff with nitric acid. Don't worry, I have much more nitric acid. That might not be enough. But yeah, we're going to start dissolving it. And then once we get it in solution, we're going to try and recover the palladium from it. Well, first we're going to recover the gold from it. Then we'll try to recover the palladium from it. Okay? And then we might try a new way that I have heard of. Well, it's not new. I've heard of it for a while. I just haven't tried it. It's new to me, okay? We're going to try a new way of purifying the silver. The scuttlebutt is it's going to be as pure as the silver cell, but a lot quicker and a lot less messy and rinse-intensive than the lye and sugar method. So we'll give it a shot and see how well it works. So, okay, let me get this in the fume hood and we'll start dissolving it. All right, I've got our relay contacts and scrap silver in the fume hood over here. First thing I'm going to do is cover it all with distilled water. Let's see here, there's not much left in this gallon, but I have more. That might be enough. Got to leave room for acid. It's going to take a fair amount of acid to dissolve all that silver. So, start putting in nitric acid. Conventional wisdom is it takes about a milliliter of azeotropic acid, which is what this is, to dissolve a gram of gold. So we got 435 grams of gold there. It's not pure. There's some gold there, but there's also palladium, which will dissolve in nitric acid. There's also probably some copper, some tin, some bronze, who knows? You know, it's who knows? Those bubbles are just air escaping, by the way. So it's probably going to take, you know, around 300 milliliters of acid to dissolve all that silver. But I'm not going to put it all in at once because we're liable to have a runaway reaction. So I'm going to measure out about 100 milliliters. Put most of that in and see what the reaction looks like. Maybe only about half of it. see what the reaction looks like. And this is all stone cold, by the way. There's no heat here yet. Look at that. Look at that. And it's going blue already. So yes, we have some copper in there clearly. Could be in the form of bronze, could be in the form of brass. The reaction isn't too crazy. So I'm going to see if I can put some more in. Let's see if I can put the whole 100 milliliters in. Okay, I can do that. And I'm realizing I have probably once again chosen too small a beaker for this reaction. I probably should have got a bigger one. But once the reaction dies down, rather than putting another 100 milliliters of acid on it immediately, I can transfer it to a larger beaker and then put some more acid on it. Look at the immediate color change though. Wow. So yeah, we've probably definitely got some brass and bronze in there, along with the silver and gold. That copper's coming from something. So, okay. We're going to let this process go. And when the reaction dies down, I'll transfer it to a bigger beaker, and we'll hit it with maybe another 100 milliliters of acid. And we'll keep that up until we get close to dissolving all of the silver. And then I'll start putting in acid in much smaller increments so that I just don't put in, don't waste a lot of nitric acid unnecessarily. So, but right now we got a heck of a great reaction going. There's no heat at all has been put on this, but the reaction itself is making a heck of a lot of heat. That beaker is very hot. So I definitely don't need to put any heat to it. Maybe later, when the reaction starts dying down, I might turn up the hot plate a little bit just to keep it going. All right, so we're just going to let this go for now and see how long it takes. All right, now it's transferred into a beaker that's got a little bit more room in it, room to maneuver. I was going to put a little less nitric acid in this time because it looked like maybe I dissolved more silver than I thought, but now when I transferred it over, there's still a whole lot of silver in there. So I think we can probably get away with putting in another 100 milliliters. We measure some out. So now that we've got a big beaker, I don't have to worry about the reaction getting too close to the top anymore. I think I'm starting to see some gold foils in there too. Yeah, I'm pretty sure I'm seeing some gold foils. Some of the gold plating is coming off, I believe. Come on, you. There we go. Get all the acid in there. So that's good. So again, I have no heat on this, but again, just putting the acid in, it's gotten quite warm. So I'm just going to leave this sit here and do its thing, probably overnight, because it's getting close to dusk. And come out in the morning and continue dealing with it. Hopefully by tomorrow we can get it all in solution and then move on from there. Okay, just going to let it go. See you tomorrow. Alrighty, it's the next morning. And whoa, look how dark blue that's got. So there's obviously more copper in there than I thought there was. Probably in the form of brass or bronze. There's a gray layer on top of the remaining silver down there. That gray layer is probably the infamous gray goo called metastatic acid. So probably there was some bronze in there. There might be some tin from solder too, but you get that gray layer when tin interacts with nitric acid. So I don't have my gloves on, which is bad practice, but let's see what we got. Oh, yeah. I think I need to put a little more water in it. I think we're getting so rich in silver nitrate here that the silver nitrate's crystallizing out. So I'm going to add some more distilled water to this, and we'll hit it with some more nitric acid and keep the good times rolling here, trying to get all this silver into solution. I'm going to glove up first. Alright, first thing I want to do, like I said, is add a little bit more water to this. Got to have enough water in there for the silver nitrate we're creating to actually dissolve in the liquid. Otherwise, it's all going to crash out of solution and just get in the way of the process continuing. You know, we'll just form a bunch of silver nitrate crystals in here. Actually, I'm going to put in a little bit more. Get around 1,100 milliliters. We'll see if that's going to be enough. We still got plenty of headroom in the beaker for more additions of acid. All right. Let's put some more nitric acid in. Speaking of acid, I'm not going to put quite as much in this time. Let's see, we've already got 200 milliliters in there. I'm thinking it's going to take something like 300. But I'm going to start cutting it back. So we've got about 100 milliliters here, but I'm not going to put it all in. So that's about, might be around 75 milliliters right there. Interestingly, we are not getting a huge reaction out of it yet. I'm going to put a little heat to it. Up till now, I've not put any heat on this, so I'm going to put a little bit of heat to it to warm it up. It's starting to bubble. All right. I'm sure the reaction will get a little more furious as it warms up. I did dilute things a lot just now, so yeah, but it's starting to bubble. All right. I'm going to put the rest of this acid back in the bottle. Rinse the remaining acid out of the beaker into there, and then we'll just let this process go and see what it looks like when it's done. Yeah, we're already starting to get some orange fumes in there, so the process is picking up. We may or may not get this done today. Turns out I have a few things to do today I didn't know about, so this may just have to sit here for a while today, but we'll see if we can get all of this silver into solution. There we go. We got a pretty good vigorous reaction going on in there. I'm sure as it continues to heat up, it'll get even more vigorous. But I definitely want to start cutting back on the amounts of nitric acid I put in, just so I don't way overshoot. It still seems like there's a lot of silver down on the bottom of that beaker, but I know as I get towards the end, it's going to start disappearing quick. Alright, we're just going to let this cook. Let it go. Okay, I'm starting to suspect there's a lot more base metal in these relay contacts than I thought there was initially. We chewed through that 75 milliliters of nitric acid pretty darn quickly. And there still seems to be a fair amount of metal on the bottom of the beaker. So I said it would take, a little over 300 milliliters of nitric acid probably to dissolve all that silver. And that might be true, but we have a lot of base metal in here, like copper, tin, and copper in particular takes a lot of nitric acid to dissolve. It takes twice as much nitric acid to dissolve a given amount of copper as it does silver. So I think the base metals in here are really eating through the nitric acid fast. And they're more reactive than the silver too, so they're going to go into solution first. So I'm going to put another 75 milliliters in it because there seems like there's still an awful lot of silver on the bottom of that beaker. So let me measure out about another 75 milliliters. That's about it right there. Put that in. Oh yeah. This time it's hot, so we get an immediate reaction. Before it was cold from sitting overnight. Okay, and we'll just continue to let that cook. Yeah. Sooner or later we'll get all that base metal in solution, and then I think the silver on the bottom is going to start disappearing real quick. Doesn't take that much nitric acid to dissolve silver compared to a lot of other metals. All right, now let it cook. All right, I think we might be about there. I've skipped a couple of additions of acid you haven't seen. They're getting smaller and smaller, but yeah, I think we're just about there. We're still getting a little bit of orange fumes off of it, but as I stir it around, there's a whole lot of metastatic acid on the bottom of the beaker and a few metallic looking things. Um, some of that might be tungsten. I forgot about the tungsten. The last time I did a bunch of these relay contacts for Johnny, there were some tungsten in them. So I suspect a lot of that stuff that's not dissolving on the bottom might be tungsten. So anyway, I'm going to let this sit for a little while longer. It's on low heat till there are no more fumes evolving, and I'll kill the heat and we'll cool it down. And once it's cool, we can filter it, and we'll see what we get in the filter. Probably some tungsten, hopefully some gold, possibly some undissolved silver, but I'd be very surprised if there was much. So we shall see. So I'm just going to let it finish doing its thing and cool down, and then we'll find out. Yeah, see, it's making some more fumes. So that last addition of acid I put in there hasn't quite been used up. There must still be a little bit of silver, something in there. All right, so we're just going to let it continue to cook, but I think we're very close to done. All right, this has cooled down. I do believe we've most likely got all the silver in solution. There might be a little bit in there that didn't dissolve, but I doubt it. Interestingly, there's a fair amount of gold in there. I can see it on the bottom of the beaker. Let me see if I can give you a look at it with my phone. There, can you see the gold? Yep, some of those contacts were clearly gold plated. So all right, we got gold as well as silver. Excellent. So what's the next step with this stuff? Well, I need to set up to filter it. I need to filter out the solids, including the gold, any undissolved silver, and the layer of metastatic acid at the bottom. So we've just got a nice cleanish silver nitrate solution. Clearly there is a lot of copper in here from how dark it is. And the fact that it's green rather than blue leads me to believe that we've probably got some palladium in there. So I think we'll probably need to recover the palladium from it too before we go on to try and get the silver out. I want to part them. I don't want the palladium to follow the silver through. I want to get rid of it, not throwing it out, just want to get it out of there. I'll add it with a palladium stocks. Just we're trying to make pure silver here is basically what we're trying to do. So we're going to take away everything that is it's silver, starting with the gold and the metastatic acid on the bottom. All right, let's get this stuff filtered. This will be the first of several filtrations, actually. But journey of 1,000 miles starts with a single step. So let's get started. Filter this green Kool-Aid here. Get all the solids out of it to begin with. Them down here in this filter. Oh yeah, there's a fair amount of gold there. More even than I thought. Nice. Nice. I don't know if you can see that. I'll have to give you a close-up look at this with my phone before I dump it in the filter. Wow. A lot of gold there. I'm liking that. Yeah, check that out. There's a lot of gold in there. I bet there's more of it hiding under that metastatic acid too. Yeah. Excellent. Alright, let me wash all this stuff down into the filter. Of course, I'm using distilled water for this because we're dealing with silver here. I don't want it to crash out of solution as silver chloride. Huh. Kind of green goo on the bottom of this beaker I'm going to have to wipe out. I need to wash this beaker down entirely anyway. Alright. There might be some gold caught in that green goo too. Alright, so I'll wipe that out with a bit of paper towel and throw it in Yanni's gold rags and filters bucket, just in case there is some gold caught in it. I'll clean that beaker. And, well, the metastatic acid is plugging the filter as I knew it would, so the last little bit of filtration is going to take a while. We'll be back when it's done. Okay, I'm pulling the last little bit of liquid off of the stuff in the filter. Ooh-wee, look at this stuff in the filter. Wow. Look at all that gold. Yanni, there's a whole lot more money here in gold than silver in these relay contacts you keep bringing me. You bring me enough of these, we're going to get rich, friend. Keep it up, all right? That's nice. It's more like we're recovering gold with a bit of a silver bonus, okay? Yeah, love those relay contacts. All right, but we are here to recover the silver in this video. We're going to try a new way of doing it, but first, I think I got some palladium here I need to get rid of. I'm going to wait for this to pull a little more of the liquid off, maybe wash it, rinse it down a bit with some distilled water. Try and get all the silver and palladium out of this stuff and down into the receiving flask. Then we'll work on it. I might set this gold aside for processing another day. Alright, I have set aside the filter with the solids in it, the metastatic acid and the gold, for later processing. I want to get back to working with the silver here. So, I'm pretty sure this green color is from a combination of blue copper and yellow palladium. So I want to get the palladium out of it. Can use some dimethylglycine for that. Yes, we can. Now, unfortunately, DMG does not dissolve very well in water at all, which is very annoying. Now, there is another method I could use. I could dissolve it in ethanol. It's much more soluble in ethanol, about as soluble as it is in anything. Problem, though, there's silver nitrate in here and probably some excess nitric acid. Everything dissolved, that would dissolve in nitric acid, so that leads me to believe there's probably some excess nitric acid in here. If you combine ethanol with silver nitrate and an excess of nitric acid, you're going to produce silver fulminate, which is an incredibly touchy high explosive. So I don't want to do that. So we're just going to have to deal with the low solubility of DMG in water. And to do that, I am just going to stir the snot out of it for a good little while here. and see how much of it I can get to dissolve in that 250, 300 milliliters of water there. All right, this is going to take a little while, a lot of stirring. It probably won't all ever dissolve, but if I can get a fair amount of it dissolved, I can put it in here, add some more water to it, and keep stirring it and see if I can get some more dissolved. I need to find something to cover the beaker with to keep debris out during this long stirring process. And suddenly, I don't seem to have any watch glasses within reach. Let me go find one. All right, there we go. We'll just let that stir for a while and see how much of it we can get in solution. All right, this has been stirring for about 15 minutes. Let me turn it off. And yeah, there's still a lot of undissolved DMG in there. Unfortunately, that's exactly what I was expecting. Okay. Let's see if we can get some of this liquid in here. It looks like some of the solids are going to come over too, but well, what can you do? Look what's happening. I do believe we are forming a yellow precipitate, a palladium DMG complex in here. And there's plenty of DMG still in here that I need to try and get dissolved, but I think it's going to take more than what I've just put in to get the job done. So we'll put a little bit more distilled water in here, and we'll stir it some more. In this particular case, I am not too worried about having an excess of DMG. Sometimes an excess of DMG is a problem. In this case, I don't see it as a problem. So I think once I get a little bit more of this stuff in there and it has a chance to react, I think you're going to see an interesting change in the liquid over here. I mean, clearly the foam on top is quite yellow, which tells me we are developing the DMG palladium complex in there. And it should separate and settle to the bottom over time. And what will happen is we'll get a yellow layer at the bottom and a blue layer at the top if I get enough DMG in there to actually get all the palladium out. Because the palladium salt is yellow, the copper salt is blue, and together they make green. Yellow and blue make green, just like in the commercial. But we're going to try and remove the yellow from it and hopefully just be left with some blue liquid here. It's going to take a while, though. I may have to let it sit overnight or even a couple of days to get it to fully separate, in my experience. So, stir that up some more. Get some more DMG in solution so I can add it to this. You see how grainy it's getting? Yeah. We're definitely getting a precipitation there. Yeah. Exactly what I was expecting to happen. Yanni's relay contacts are just so full of palladium. I haven't figured out whether they're plated with palladium or they are alloyed with it, one or the other. But there's a lot of palladium in his contacts. So I always have to do this to separate the palladium out before I go after the silver. Which is not a bad thing, because the palladium is worth a lot more money than the silver. So there's lots of value here. You got the gold, the palladium, and the silver. Probably in about that order of value in these things. But okay. So I'm just going to let this stir some more, add some more of it to this, and then probably let it sit at least overnight. And we'll see what it looks like after it's had a chance to separate good. All right, I poured the rest of the DMG solution in there. There's a little bit of undissolved DMG floating on the surface. I'm not too worried about that. That'll all get filtered out eventually. The one thing I am worried about is I'm not sure I used enough DMG water in here. We'll have to let it settle and see if it actually goes blue on top, and that can take a while. And I probably once again used too small a beaker since we are full up. But I'm just going to let this sit for now and see how it looks. I'm going to put it in the fume hood, just stash it in there for safekeeping. And we'll see as it separates whether it looks like I got enough DMG in it. If it's not enough, I'll transfer it to a bigger beaker and give it another treatment. Well, here we are after this stuff sitting for about 24 hours. It's not in any hurry to separate, is it? Wow. But it is separating a little bit. You can see we've got nice blue liquid up there now. We've gotten the palladium out of it. It's just copper in there giving it color, but the palladium isn't settling. Well, I just got home from work and just checked on this. I don't have time to deal with it tonight, so we're just going to let it sit for a while longer. I've got a feeling I'm just going to have to filter this stuff to separate the palladium out. I mean, I was going to filter it anyway, but I was hoping it would settle better because this stuff's going to clog my filters real quick. And I was hoping to get the bulk of the liquid through. I suppose I could let it sit for a couple weeks, but, well, I think I need to process it sooner than that and move on to other projects. We'll see what it looks like tomorrow or the next day when I have time to work on it. Alright, it's been another 48 hours, and this stuff just is not settling. I've never seen this happen before, where the palladium salt doesn't settle out. The only thing I can think of is there's an inordinately large amount of it in this batch. Now, it may not look like it from this angle, but if I come down here, oh yeah, that's nice and blue, that liquid on top. So I think we've got all the palladium out of it. It's just a matter of separating the yellow palladium salt from the blue liquid now. I was hoping it would settle some more, which would make it easier to filter the bulk of the liquid, but, well, no such luck. So we're just going to go ahead and vacuum filter it here. It's probably going to take quite a while because I'm sure that palladium salt's going to plug the filter. But we need to separate the two before we move on. So let me get started doing that. Okay, so let's start this filtration. Alright, there's too much liquid in here for me to try to pour it out, so I'm going to dip it to start with anyway. Oh yeah, that's coming through nice and blue. Alright, good. And we're already accumulating a lot of yellow-orange palladium salt up here in the filter. I got a feeling we're going to get a lot. Now, it's not the first time I've done this. I've done kilos of relay contacts for Yanni, and they all seem to come loaded down with palladium. So I'm getting quite a collection of filters full of palladium salt. And someday, we're going to process all those filters and see if we can get the palladium back out of them. So, subscribe to see that in the future. Once I get this filtration done, though, I'm just going to add this filter to the growing collection for now. Anyway, once I get all this stuff through, I'll give you a look at what we've got in the filter. It's already turning into an impressive amount of yellow-orange palladium salt. Okay, it's just going to take a while. That filter's plugging up already. But yeah, I would say we got all the palladium out of it based on the color of what's coming through. Pure blue. No more green. We've separated the yellow palladium out. Nice. So here's what it looks like in the filter now that all the liquid's through. Yeah, it looked like a lot of palladium salt in the bulk, but once you get it in the filter and it all compresses and dewaters, there's just a thin layer of it. I don't know why it wouldn't consolidate. Kind of weird. Anyway, my receiving flask is full to the brim. I need to put a lot of rinse water through here to get the silver out of it, so I'm going to have to change to my smaller receiving flask to do that. And then we'll put all this stuff into a bigger beaker, because that one was full to the brim. Then we'll work on recovering the silver from the blue liquid here. We'll talk about ways we can do that. Okay, let me change over here. Go. Put some distilled water through here. Pull the silver solution through off of the palladium salt. Alright, I need to refill my squirt bottle with some more distilled water. I'll give it a couple more treatments to make sure I get as much of the silver off of that palladium as I can. I have no illusions I'm going to get it all. We'll have to part the silver and the palladium at some point in the future. But that's a problem for future Mike. Alright, let me refill my squirt bottle and get all that silver out of there that I can. Alright, there is the palladium salt cleaned up. Looking pretty good. And I will get this liquid into a bigger beaker. I'm going to let the vacuum go for a while and pull as much liquid off of the stuff up here as it can. Then I'll get these into a bigger beaker and we will go forward from there. Alright, the palladium salts are safely put away in here with a bunch of other filters full of palladium salts. Got our pretty blue fluid over here, almost 2.5 liters of it. So, how am I going to get the silver out of this stuff? We've removed the gold, we've removed the palladium. Now I want to remove the silver from this liquid. How are we going to do that? Well, there's a couple of different ways. You've seen me just put some copper pipe in there before and cement the silver out. I do that a lot. Yeah, but I don't think we're going to do that this time. I think we're going to try something else. I could put in hydrochloric acid or sodium chloride solution and precipitate the silver out as silver chloride and then use lye and sugar method or a couple of other methods to convert it back to silver. But yeah, I don't think we're going to do that this time either. I think we're going to try something different. Something I've only done once before, okay? And it worked surprisingly well. So I think what we're going to do is we're going to precipitate out the silver using vitamin C or ascorbic acid. So I'm going to dissolve some ascorbic acid in some distilled water, and we're going to pour it in there, and we're going to see what happens. Now, there's a couple of different ways you could do this. I think we're going to have some copper contamination in the silver that's produced because this is really, really copper contaminated. You can tell from the blue color. So I'm not too worried about that because this silver is going to run through my silver cell, my silver refining cell, the electrolytic cell. It's going to come out 99.99% almost, 4 nines pure. So I'm not worried about a little copper contamination since this is all going to go through the silver cell. But there is a way to do this and get, supposedly, silver that's about as pure as you get out of the silver cell. What you would do is, like I said before, add hydrochloric acid to this or sodium chloride solution and precipitate out the silver is silver chloride. Rinse the silver chloride really, really, really well to get all traces of copper out using the ammonia test to make sure there's no copper left in there, because ammonia solution will turn bright blue if there's even the slightest trace of copper present. So that's a pretty good test for that. And then once you have really, really clean silver chloride, what you can do is dissolve it in ammonia, add this stuff to it, and it will precipitate out as very, very pure silver. There's a lot of steps to that. I think we're going to take a shortcut today and just try and precipitate out the silver directly out of this with some ascorbic acid and see how it goes. Now, the literature I've seen says you need about a 1 to 1.5 times the amount of ascorbic acid for the amount of silver you have in here. And, we had what? 400 and some, I don't remember the exact number. I'll have to go back and look at the video. But I know if we put, about 420 or 30 grams of ascorbic acid in here, maybe make it 450, that's probably going to be enough to precipitate out all the silver, because there was other stuff there. There was gold, there was tin, there was copper, and there was palladium. So it wasn't all silver, that went in there. So I'm thinking, yeah, we'll go 450 grams of ascorbic acid and see if we can precipitate out the silver. We can always test the liquid to see if it has any silver still in it after we precipitate all the silver out. If so, I can put more ascorbic acid in. So we won't lose any. Anyway, that is a lot of ascorbic acid to dissolve. So I'm going to put about 1 liter of distilled water in this beaker here, and I'm going to put it on the heat and warm it up to make the ascorbic acid a little more soluble. And then we'll weigh out about 450 grams of it and see if we can get it all to dissolve. So let me get this on the heat and get it warmed up. All right, while we're waiting for the water to heat up on the hot plate there, let's weigh out about 450 grams of ascorbic acid. It's going to take a lot, I think. Yeah. To make 450 grams, because it's not a very dense material. By the way, there will be links to all the chemicals and a lot of the equipment I'm using down in the description of the video if you want to try this at home. Be very, very careful, because this silver nitrate back here is very dangerous. I managed to get a bad chemical burn from it not too long ago. Fortunately, it's all healed up now, but I do have a scar. But I can put a link to that video in the upper right. You want to check that out. I never really thought of silver nitrate solution, especially with no free nitric acid in it, as being particularly dangerous. But sure enough, it stays on your skin for a while, which happened in my case because a little bit of it hit my sock and I didn't realize it, soaked through the sock and into my ankle. It'll give you a nasty chemical burn. So, yeah, be careful. Now, vitamin C here is pretty benign, but still, be careful with it. Wear your PPE. Want to get it in your eyes. Okay, 455, we're going to leave it at that. That's probably close enough. A little more than I was aiming for, just in case it takes a bit more. Now, I hope I can get this all dissolved in 1 liter of hot water. If not, I'll just add more water to it. I put it in this big beaker over here because I wasn't sure just how much water we were going to need to dissolve all this ascorbic acid. Like I said, I've only done this once before. So, and it was on a small sample of silver nitrate just to see if it worked. So I did it off camera. So I do a lot of work off camera, so I don't look like a complete goof on camera. Still, I manage it quite a bit of the time anyway, to look like a complete goof, that is. So, all right, we'll let that water get hot. We'll see if we can dissolve all this, and then we'll see if we can precipitate that silver. All right, I pulled the water off of the hot plate. It's not quite boiling. Where are we here? Ooh, not as hot as I thought. Only about 70 C, but we'll see if this is going to work. And get all this stuff dissolved in there. Like I said, if not, I'll just add more water to it. Well, most of it's already gone into solution, I'd say, so give it some serious agitation here. I'd say it's dissolving. Nice. All right. I'm going to stir it a little bit more, see if I can get it to make sure it's all dissolved and get it to clarify a little bit. Then we'll see if we can precipitate out that silver. Let me get a little bit more out of here. Okay. Yeah, look at that. That all went into solution nicely. All right, so let's get set up to precipitate out the silver and see how this works. All righty, let's see if we can precipitate ourselves some silver. We got our ascorbic acid solution here. It's all dissolved. We got our silver nitrate solution here. I've got my GoPro going too. We'll see what it sees when I pour this stuff in. So let me zoom the main camera in. You can see what's going on here. And let's pour it in. Look at that. Look at that. Wow. That is just instant. Absolutely instant. I love it. If I put either some copper pipe or one of my copper ingots in there, like I do often, it takes a couple of days to precipitate all of the silver out of solution. But look how quick that was. We got quite the scum of silver floating on top too. I'll give you a close-up look at that with my phone. Yeah, look at that. All right. Let me stir it up a little bit. See if I can get this floating silver to sink. In fact, what I would like is for all the silver to sink to the bottom. We'll see if I'm any luckier at that than I was with the palladium salt, getting it to sink. And I'd like to get a clear layer of the blue liquid so we can do a test on it to see if there's still any silver nitrate dissolved in it. If there is, I'll dissolve some more ascorbic acid in water and put it in there to make sure we get all of the silver out of the solution. I don't want to leave any behind. But yeah, that is absolutely instant. I love that. It just doesn't have to sit on my workbench for 2 or 3 days until I'm sure all of the silver is out of solution. That's wonderful. Yeah, look at that. Look at that pile of silver down there. Holy moly. Yeah. Very nice. And we know there's a little under a pound of silver in this thing. Should be anyway. Very nice. Okay. I'm going to wash down the inside of the beaker, get all the silver off the sides, and we'll see what the GoPro came up with during that. All right, this liquid has had a chance to settle. We've got a nice clear layer up here near the top. It's time to check it and see if we have any silver nitrate still in solution. So I've got here some tap water with a little splash of hydrochloric acid in it. So if I get some of this clear liquid out of here and I put it in there, if there's any silver nitrate in it, we should get a white cloud of silver chloride. I do not see a white cloud forming. A little more in. No, the liquid's turned a little bit blue-green. That's it. Yeah, so there's nothing. That tells me all the silver's down there on the bottom of that beaker. Excellent. That was nice and quick. Unlike days using the cementation process or, you know, so many steps and so much rinsing with the lye and sugar method. So this is really great. So what I need to do now is set up to filter this. Filter this liquid off, capture all the silver. So that's what we'll do next. All right, this stuff's had plenty of time to settle. I think it's time to filter the liquid off and capture all the silver down in here. Now, you notice this has gone dark green again. What's going on? Is the palladium back? No. We got rid of the palladium. The thing about copper is most of its compounds are either blue or green or sometimes brown, depending on the oxidation state of the copper. And we went from blue copper nitrate in here to green. I'm pretty sure what we've got here is a copper ascorbate complex, which is green, at least according to Wikipedia. So, yeah, I'm pretty sure that's what we've got here is copper ascorbate complex. And, well, it's just gone green again, but that's okay. I'm going to filter this liquid off. I've got a little over 3.5 liters of liquid here, so I'm going to have to empty this out a couple of times as I pull the liquid off. There's a lot of copper in here. We're going to capture that copper in my waste process, and we'll get it back. I have videos on that. I can put a link to one in the upper right where I recover copper from my waste liquids and actually pour some ingots from it. I need to do that again in the future. So, all right, so let's get to filtering. Oh, that's heavy. It's a lot of liquid. Going to take a little while, especially once the filter starts getting plugged with silver. So I won't make you watch the whole process. I'll be back when I've got the silver in here and I'm ready to start rinsing it with distilled water to get the green nastiness out of it. Well, would you look at the pile of cement silver in this beaker? My goodness. And this is a 5-liter beaker. That's a lot of cement silver. Well, I wouldn't say cement. Precipitated. I precipitated. I didn't cement it this time. Well, wow. I'm starting to wonder if it'll all fit in my ridiculously large Buckner funnel down there. That's a good question. Of course, I know it'll probably compact a lot once I de-water it, so maybe it'll be okay. But wow, that's a lot of silver. Well, what do you know? It all did fit in there. Yep, it's shrinking down nice as it de-waters. Still got green stuff coming off of it. I've got some water heating up in the fume hood on a hot plate to give this some rinses to try and get more of the green stuff out of it. So I'll start giving it rinses here shortly once the water warms up. Alright, I think we're ready for some hot water rinses here. I got a lot of the green stuff out of it just by spritzing it with some distilled water. up here, but this should do a pretty good job of, yeah, clean it up. Good. Let me break up some of the clods up here and give it a couple more rinses. Yeah, it's coming through pretty clean. All right. Get the rest of this water through, and I think we'll call it good enough. Since I'm going to melt this stuff down and make anode bars for the silver refining cell, I don't think it needs to be really any cleaner than this. It'll come out of the cell close to 4.9's fine. So excellent. All right, I'm just going to let the vacuum run and dewater it as much as possible. And then I'll pull the filter out, put it on in a Corningware dish on the hot plate on low heat, and we'll dry the silver out. And once it's good and dry, we can weigh it and see what we got here. I mean, it looks like a lot, but I know from experience, cement silver, and well, this stuff too, looks will be deceiving once it's dry. It won't be that heavy. Okay. Just let it dewater for a while. Alright, gonna leave this stuff in the fume hood on low heat with the blower going and dry it out. I'm sure it's gonna take a little while, but that's okay. I got all day. Get it good and dry, then we'll give it a weigh. Alright, so that took most of the day, but the silver is now all dried out. And I'll tell you what, this process for recovering the silver produces a much finer silver powder than the cementation process does. And it agglomerates together into hard clods as it dries out. I noticed this on my prototype when I prototyped this process. I did that off camera and I thought, this is some super fine silver. All right, let's weigh it and see how much we've got here. See if I can get it into the beaker. No, because the filter paper is falling apart. Okay. I'm glad it didn't fall apart when I had it up in the air. Get this stuff in here. There's some more paper. That out of there. Yeah, definitely hard lumps. It's good and dry though. I'm sure about that. And one of those hard lumps just went on the floor. See if I can find it. There it is. Blow it off like a pill that fell on the floor. All right, 292 grams. All right. I'll see if I can calculate a yield for silver and put that up here. But remember, we also got a fair amount of gold out of these and some palladium. And there was copper too, a lot of copper. So yeah, we may have started out with 400 and some grams. I don't remember the exact number. It was like 446 or something, was it? I'm probably wrong. But yeah, obviously it was not all silver. There was a lot of other stuff there. Yeah, including good stuff like gold and palladium. But yeah, there was a lot of copper too. So yeah, that's why we're down to 292 grams. Still, that's a respectable amount of silver. I'm going to put this in a container that I have some other silver in, and the next time I cast anode bars for the silver refining cell, I will use this stuff, and we'll run this through the cell and clean it up to almost 4.9's fine. And at some point in the not too distant future, I'm going to cast some little bars and ingots for my friend Yanni for when he's back in town. So subscribe to see that. And subscribe to see all the other stuff I'm doing. I've got some other interesting stuff coming down the pike. I think you'll like it. So, I'll see you in the next video. If you guys found this video at all interesting, educational, informative, inspirational, whatever, give it a like, give it a thumbs up, and I'll see you in the next video. Bye.